This is Nidhi from Edulyx powered by Science Adda, and today I welcome you to another episode of Edulyx. So today we are going to talk about a very interesting topic. We are talking about bridges. Humans have reached very distant lands that are very difficult to reach otherwise, and one of the main reasons for us reaching to those areas are bridges. So what makes bridges strong and what makes them capable of holding so much weight? And what makes them stand for this long? So let's see what do we need for the activity we are going to try to test the strength of bridges. We need two markers, a sheet of paper and some coins. So what we are going to do is we are going to place the sheet of paper over this and then start placing coins on it. 2, 3, 4, 5, 6, 7, and you can see the bridge went down. So now what we'll do is we'll fold it into a fan like structure. And keep it over the markers. So let's see how much coins it can hold. 1, 2, 3, 4, 5, 6, 7, 8. So you can see I've placed 46 coins over this bridge and it's still holding. So why does this happen? The question is, how does a sheet of paper that was not unable to hold the weight before is now unable to hold so much of weight? So the answer is triangles. So when we folded the sheet of the paper into a fan, we made so many triangles into it. So triangle is the structure which can hold both the forces of compression as well as tension. So tension and compression are the two forces experienced by most of the bridges. So what is compression? Compression is when the structure is pushed from upside down and it is squashed. And tension is when it's stretched between two ends and it's expanded. So triangles are the only structures that are very resilient to these kinds of forces, both of tension and compression. For most of the structures, tension works the same way by stretching up the shape, be it rectangle, be it square. But compression works differently for different shapes. If we talk about a square, when we compress it, it turns into a rhombus. And triangle is the only structure that can be resilient to both tension and compression, due to which most of the bridges are of truss structure. Even the Howrah Bridge in the Kolkata is also of truss structure. So now what you have to do is place two sheets of paper, one above and one below this truss shape, and see how much weight can the bridge hold. There are many other kinds of bridges too, which you can try making with a sheet of paper and see how much weight do they hold, and post your videos on Instagram and Facebook by tagging us at @Edulyx. You can also download a game called Build a Bridge from Play Store and try building bridges from different materials of different structures and see how strong are those bridges, and you can post your comments and your experiences in the comment section below. Hope you like the video. Please leave your comments in the comment section below and do not forget to like, share and subscribe our channel Edulyx. Thank you.